Yeah, welcome to the class. Today we are going to study the relationship between acceleration and velocity with an activity. Activity in the lesson motion. Relation between acceleration and velocity. So what is the aim? It is to find the acceleration and velocity of an object moving on an inclined plane. Yeah, once again, it is to find the relationship between acceleration and velocity of an object moving on an inclined plane. This is what you mean by an inclined plane. Right? To create this inclination, I am taking the help of books. Now we'll see the same thing. Here, it is here. Right? To create this activity, to study about this activity, these are the required materials you require. You require a glass marble, a long plastic tube which is actually used for creating a track, books to make the track inclined, so books to make the track inclined. Then you require a steel plate. Here is the steel plate, and steel plate should be kept exactly at the end of the track. So to create a track, we will be using a plastic tube. So we'll be using a plastic tube, okay, plastic. When you cut the pipe, okay, into two halves, that's called plastic tube. So you are going to drop a marble from different heights, say 40, 60, 80, and so on. So it is like that. Then you also require a digital clock or a stop watch, because you have to take the trials for each height. Say 40 centimeter, you are dropping the marble from 40, so you are going to do the same 40 for three trials. So trial 1, trial 2, trial 3. To record this time, you require digital watch or a stop watch. So right now let us start. So we are going to find acceleration and velocity of an object when it is moving on an inclined plane. So first one, what is that? I told you, no, plastic pipe. A plastic pipe you have to take and cut it into two halves. So one half you are going to use it for this activity. So cut a plastic tube lengthwise to make a track, because when you want to drop a ball, if it is a track like this, it's a track. It is track. So automatically what happens? Ball rolls down like this, right? The next thing is what? Raise one end of the ear. So you want to create a track, you want to drop the ball, so you have to increase the inclination of this track. Therefore you require books. So you require plenty of books, say 5 6 books. It depends upon, okay, if you put two books, then inclination will be less. If you increase the more number of books, then inclination will be more, slope will be more. So same way, next one is mark distances. Okay, so you're going to mark the distance as it is already indicated here, 40, 60, 80, like that. You're going to mark it on the track. Next, keep a steel plate at the end of the track. Yeah, I already told you, no, metal plate you are keeping exactly at the end of the track. Then next, release the marble from the mark position. So if you want to release the marble from say 40, you do it for 3 times. The moment you're leaving it, you have to leave it. You should not push it. You're not supposed to push it. Just you keep the marble at 40 and you have to leave it. The moment you leave, you have to switch on the digital clock. So these are the some of the things, right? Measure the time taken by the marble to what reach the steel plate. So steel plate is kept exactly at the end of the track. So the moment it hits, you will switch off the digital clock and you'll take down the time for first trial. Then you'll do the same thing at same height for the second trial, third trial, and you're going to take the average of these three. That is what you mean. Average time is T. Suppose whatever you get here, the right time taken here is a 10, here it is 12, and here it is 10. So you're going to do the average of 32, 32 at 10, 12, and 10 is 32, isn't it? 32 by 3. Why 3? Because you have taken 3 trials. So that is called average time. And then actually distance, you are going to measure, take the distance. As I already told you, you're going to drop the marble at a distance of, say, at an height of, say, from the at a distance, sorry, at a distance of 40, 80, and 60, and so on. Okay, now what happens? What is happening? You're going to calculate yes, right? S is equal to ut plus half at square. Since you're just dropping, it's like a freely falling body. U is always 0. Therefore U is 0. U into anything is 0. So what is left over here? S is equal to at square by 2. That is nothing but cross multiply. You will get at square is equal to 2s. Now our activity is to find acceleration only, the relationship between acceleration and velocity. Therefore, acceleration is equal to a is equal to, it is 2s by t square. So you are going to do the same thing here. This is an activity to find the relationship between acceleration and velocity.